Okay, so now we went through everything yesterday with Chapter 1 review. Did anybody have any other questions on Chapter 1 before we just go ahead and jump into Chapter 2? Anybody looking something over? All right, perfect. Let's go ahead and get started on Chapter 2. And we kind of did a little of this already, but let's just review, all right, just to make sure you're good. A number n added to 18. Remember what we said. What are you starting with? Are you starting with a number or are you starting with 18? You're starting with?
18.
That's correct. So we want 18. And then you're adding what? N. Now remember we said is in math means equals. So here we go. 18 plus n equals. Now 7 times the difference. When there are two operations in a row, times the difference. What do we say we need?
Parentheses.
Parentheses. Good. So we have 7 times the difference of n and 3. All right, double check that. Make sure you understand that. All right, I think that's about as hard as it can get as far as the translations go for now. All right, everybody should know if I said what's the area of a triangle, you all should just be able to tell me area equals what?
BH divided by 2.
1/2 base times height, BH divided by 2. So I want to write both of those so you can understand the fractions just as a good review. 1/2 base times height is the same exact thing as base times height what? Divided by 2. All right, you have to know that. All right. Now let's continue on. Now, again, some of the equations here, what?
On the test, does it matter which one?
No, I don't. Nope, they're all the same. All right. Good question. Now, for these here, a lot of it we said was mental math, correct? All right. But let's review. We're always trying to isolate the variable. So if we're going to try to isolate the variable, that means we have to get rid of all the other numbers around it. All right? And keep in mind, this is a plus 7. So how do I get rid of a plus 7? We just do what? Subtract 7. Right? I know everybody in here knows that. All right? I'm not expecting you to go minus 7 like we did last year. All right? I'm just expecting you to say, hey, I know that t is equal to what? 4. Just like over here, I'm trying to get rid of a what? Minus 12. To get rid of a minus 12, I just do what? Add 12. So here we have v is equal to 7. Beautiful. All right. Now, again, we're trying to get rid of this negative 8. That's held together by multiplication. So how do I undo multiplication? Divide. So everybody should be able to tell me that x is equal to what?
7.
All right, I'm pretty happy with that. All right, x is equal to 7. Now, it's obviously going to get harder because you've worked. So if you don't understand these, you're not going to understand the other ones, correct? All right, so make sure you're speaking up. Whenever you don't know something, speak up. All right. Now, the next thing we talked about, which is super important, I'm glad we're reviewing, how do I undo a fraction? What do I say to do? Who remembers? What was it? Multiply by the reciprocal. You always multiply by the reciprocal. We're going to show you right now. First thing I'm going to do is I don't like this 6 being there. So I'm going to erase that. All right. Well, you just change it to white. All right. You change your color to white and it whites out. All right. So now, here we go. I'm going to multiply by the reciprocal. So I'm going to show you exactly what I need for you to do. All right. When you multiply by the reciprocal would be negative 9/7. Right. And then over here we would multiply by negative 9/7. Now, why do we do that? Because what is true when you do negative times a negative? That does what to each other? Cancels out. Makes it a positive. What happens to the 9 and what happens to the 9? They cancel. What happens to the 7s? They cancel. And our objective was to isolate the y. Is the y value isolated? We would say what? We would say yes. It's all by itself now. All right. Now, I think this is where we got left off, or we kind of left off, if I'm not mistaken. And some of you walked out of here not 100% sure how we do these fractions. You guys should be experts at fractions. So you should be able to look at that and just say y is equal to, what was it? 54 over 7. If you forgot, you just make that 6 over 1. Multiply numerators, multiply denominators. When you get into advanced math, we only use improper fractions. We don't use mixed fractions. We do not use mixed. This is the correct answer, 54 over 7. I don't want you to say 7 and 5/7. Yes?
Did you, so you did 6 times, -6 times -9.
Of course. Right? Now look, here's something I'm going to try to teach you guys as we go out for the next couple of years. Listen to me. He wasn't sure how we got 54. Right? And you might not be sure how I got 54. But what I want you to be able to tell me is the only way to make 54 with 9 and 6 is to do what? So I must have what? I must have multiplied. Then you're learning on your own. You see what I'm saying? Just like over here, how did I get that 7? The only way to get 7 is with 7 and 1 is to do what? So now you remember how to multiply fractions. What?
Isn't the reciprocal if it's
No. Don't. What's the question?
I didn't know if it's a negative, if you do the reciprocal.
Well, what did I do?
It makes it negative.
What did I do?
Which makes it negative.
Exactly. So listen, guys, I'm pretty confident. So if I write it up on the board, guess what? It's probably right. All right? Very rare are my mistakes. And you'll let me know when I make one for sure. All right? But I promise you, all right, when it's up here, all right, I'm trying to correct your thoughts. All right, I'm trying to correct your thoughts. So as we go down, it's easier for you. All right? So when there is a negative, if you don't multiply by a negative, the y value will stay what? It'll stay negative. And we want the variable always to be positive 1, actually. All right? Because actually the number in front of this y right here is a what? Is a 1. Everybody happy with that? Everybody good? Okay. Now, for number 7, all right, I'm going to try to show you something here too now. All right? This is fraction bar, which means what? Division. So how do I undo division? Multiply. So I'm just going to have to multiply both sides by what? Multiply both sides by what? Thank you very much. 135. So I'm going to erase this again just so I can show you. All right. So I'm going to multiply both sides by, I like what you said, 135. And I'm going to put 135 over here. Now watch. This and this cancels. Right? So I'm pretty sure everybody say, well, just A is 50, right? We don't have to do the work on that. That's just brilliant mental math, correct? Everybody knew that was 50 just by looking at it, correct?
Yeah.
Now let's say you're going, wow, that's pretty good. I don't know what you just did. So now I'm going to try to teach you how you can do the arithmetic in your head. All right? First of all, I always like to do the division first. Everybody agree? All right, because the number gets smaller. And then multiplying by 10 is not really that big a deal. Everybody agree with that? So let's say you didn't see 135 divided by 27 was 5. Let's just say you didn't see that. All right? I would hope you'd be able to look at that and say, well, I know 9 goes into 27, right? And I know 9 goes into 135. How did I know 9 goes into 135? Because I added the digits up real quick. Remember that? 1 plus 3 plus 5 is 9, so I know it's divisible by 9. All right? So instead of doing long division, we never do long division. We treat it as a fraction. And let me show you exactly what I mean by that. I'm doing 135 divided by 27. That's how I do it. And I just reduce it like it was a fraction. I know I can divide both by what? 9. So now I know the easy one is 3. Now watch how I do the division. I'm amazed at people, didn't know how to do long division in their head. All right? So we're dividing by 9, right? So 9 goes into 13 how many times? Once. Thank you. I know 9 goes into 135 15 times. Thank you. But we're starting with 13. So when you subtract 9 from 13, you get what? 4. So in my head, I place the 4 right there. Now I'm looking at the number what? 45, right? And so now I'm just doing 9 goes into 45. And now I can do 15 divided by 3 rather quickly. Do I agree with that? Right. So again, the other thing I want to show you is generally, if this ends in 5, the answer probably is what? 5. Do you agree with that? All right, so there's lots of ways. We're going to practice our mental math on chapters probably 1 and 2 and 3, and then we're going to start using calculators. All right? But you really need to be better at your mental math. All right, so that's what we're going to concentrate on. And then, of course, once we divided this out and got 5, it was just 5 times 10, which is 50. Does everybody agree with that? Any questions? All right, so now we get into what's referred to as a two-step equation, all right, which I know you guys did last year. All right, so remember you're isolating the variable. So again, we're doing PEMDAS backwards, so to speak. All right, so we always did addition and subtraction last. Now we're going to do addition and subtraction what? First, because we're working backwards. All right, hopefully that makes sense. All right, so how do I get rid of a plus 3? Minus 3. Now here's what I'm expecting from you guys. I'm subtracting 3, right? So the first thing that's going to be written down is negative 5b equals negative what? Negative 35. And then I would be dividing, correct? But again, we can do the mental math on that. So b is just what?
7.
B is 7. All right? That was not that hard. All right, now again, trust me, it's getting harder. So if you don't know that, you got to speak up right away. Yes, ma'am.
I don't really understand
35 divided by 5.
Okay.
You with me?
Oh, I see.
Because this is what? This is multiplication. To undo multiplication, we divide. What?
How did you get negative 35?
I subtracted 3 from both sides. So I'm going to draw this out for you now. Since some of you asked me a question, I'll show you the actual work. So I just did what? Minus 3, minus 3.
Okay.
Are we good on that?
Yeah.
And then I did what? I divided by negative 5, divided by negative 5. All right, but that's just basic two-step equations, we said. Very simple. Working backwards.
So you got the negative 5b because you just moved it down?
I divided both sides by negative 5.
Okay.
Right? This was isolated after I got rid of the 3.
So you're always going to isolate the variable?
Very, very good.
Okay.
All right. Now we have to write the equation. Number 9. What number decreased by 8.1 equals 4.9? Tell me the equation.
8.1 minus a equals 4.9.
Okay, listen to me now real carefully. So are we starting with 8.1 or are we starting with the variable?
8.1.
So what number decreased by 8.1? Do you see what? Now listen, I'm not trying to tell you what the answer is. This is very hard for me to teach. One of the very few things for me is very difficult because to me it's a visual thing. Right? Does everybody hear me on this? You're either starting at a number or you're starting at 8.1. What are you subtracting? Are you subtracting the number or are you subtracting 8.1? You're subtracting what? You're subtracting the 8.1. All right, and again, like I said, I don't care when you make mistakes. I want you to make mistakes. It's easier for me to help you if I know you're making mistakes. So right here, I want you to be real careful. You have to, not always is the variable first or not always is the variable second. You have to say it. So in this case, it's actually whatever number you want. What number did you say? What letter did you say?
A.
A minus 8.1 equals 4.9. That's what you should have written down. If you don't have that written down, you can kind of just correct it. It's not a big deal. Now, how do I get rid of minus 8.1? I just do what? Say it.
Add 8.1.
Add 8.1. All right, now again, you're just practicing your decimals. All right, so in this case, A is definitely what? 13. Beautiful. I think that's pretty easy, right?
Yeah.
A is 13. Now remember, I'm not a mind reader, so if you don't know, you got to tell me. If you don't know, you got to tell me. All right? Now, number 10. This is another really important problem. Am I starting with 15 or am I adding 15? Tell me. You are adding 15. So here's what you do. You put plus 15. What am I adding 15 to? Tell me.
N plus 6.
15 is added to, what does product mean?
Multiplication, sorry, times.
That's right. So it would be a product of a number and 6. So we could say 6n. Agreed?
Yes.
Equals what?
9.
Equals 9. There you have it. All right, so now this is what I'm talking about, your mental math. First thing I have to do is get rid of what? Tell me.
6.
No. What? No. Tell me.
15.
You have to get rid of the 15. Remember, we're doing PEMDAS backwards. We're doing PEMDAS backwards. All right? So we always have to eliminate when we're solving an equation, you're what? Adding and subtracting. All right? So the first thing I'm going to do is subtract 15. So I'm going to put a minus 15 and a minus 15. Everybody happy with that?
Yes.
All right. And so now 6n equals what?
4.
6n equals?
-1.
Good. -6, I think. All right. And now what? Tell me.
-6 divided by 6.
That's exactly correct. So n equals what?
-1.
Beautiful. N equals -1. Wasn't bad, right? Not bad. All right. So here we go. So let's look at, again, what's beautiful about your iPad is I can move this up, shrink it down, and put it right in its spot where it needs to go. All right. And you can look at it later. Number 11. During an evening out, Dean paid a cab driver $20. He then spent $25 on dinner and half of his remaining money on a painting. He bought an umbrella for $23.75 and had $42.15 left. How much money did Dean have at the beginning of the evening? All right. What'd you get?
101.
101.
177.
Good.
176.8.
Good.
Same thing, 176.8.
Good. Don't be afraid. Look, if you want to say $5, you can say $5. Doesn't matter. Speak up. Be brave.
I got 110.95 cents.
110.95. Yes, sir.
176.8.
What'd you get?
111.
111. Anybody else?
107.
107.
176.
Good.
I got 110.9.
Good.
110.
All right. Let's see. All right. Let's see who's right. Okay. So, during an evening out, Dean paid a cab driver $20. All right. So, first of all, do we know how much money we started with? No, we don't. So, what can we use? A variable. What variable do we want to use?
W.
X. I like X. I'm old-fashioned. X is good. All right, so here we go. Let's do X. All right. So he first thing he did was he paid a cab driver what? 20. So what happens to our money?
That goes right.
Yeah, so we subtract 20. Right? He then spent what? $25 on dinner, right? So we're going to do what again? We're going to subtract another 25, right? No, it doesn't matter. Remember? And then it says, and half of his remaining money on a painting. So this is so this is what's I think tricky. What do I have to do here?
Minus 1 half.
Half of what though?
Of X.
What do you think?
I think you look at the second part of the problem because that would probably be half of the money.
Okay, so let's say, for example, I'm gonna help you out now. Pay attention, please. Right, and I'm gonna show you how to do a good job, better thinking, because sometimes it's very difficult to see. But if you make up a number, it's sometimes easier. So let me show you something. So let's just say we started with $200. He spent $20 on a cab, right? So now what? How much money does he have? 180. Then he spent $25 on dinner. So now how much money does he have? 155. Now how do you subtract 25 quickly? You subtract 20 and then you subtract 5. So 180 minus 20 is 160, minus 5 is 155. All right? Then he spent half of the remaining money. Well, how much money does he have? So I have to do what with 155? I just cut it in half. Does everybody agree? And if I cut it in half, of course, everybody knows that's 77.5, right? Now, do I have to subtract that from 155 to get how much money I have left? Hello? Do I have to subtract to get how much money I'm going to get left?
Well,
That is how much I have left, because that is what? Half. So you're giving half away and you're keeping what? Half. So what do I have to do with this quantity now? What do I have to do with this quantity? What do I have to do to it? Divide that by 2. Thank you. Very good. So now why did I know I was dividing that by 2? Because that's what I did here, and that's what we've been doing. So I'm trying to show you, does everybody understand how if you did it with numbers, it's easier than seeing it with the variables? Does everybody agree with that? All right, I'm hoping you can get that. All right, that's a good skill to have when you're taking standardized tests. All right, that's how I clear up a lot of my own questions, because it's easier for me to see numbers rather than variables. All right, so I'm going to take this part right here, and I'm going to divide this whole thing by what?
2.
By 2. And that's how much money I have right now. Does everybody agree?
Yeah.
All right. Then he bought an umbrella for $23.75. So what do I do now with my money? Tell me. That's right. I now do minus 23.75. Now how much money do I have left? So all of that is equal to what? All that is equal to $42.15. That's kind of what I want you to have down. All right. Now, do I think that problem's hard? I think that problem's really hard. Yes. Well, we're not there yet. We're not at the answer because we're trying to figure out how much we started with. So now I have to go back to do what? I have to solve for what? X. Everybody with me? I'm going to solve for X now. And like I said, I thought that was hard. All right. So let's see. All right. Now I'm working backwards. All right. So minus 23.75, I should do what? Add the 23.75, right? So if I add, come on now, we're going to do mental math here. So I want eyes up. 23 plus 42. Everybody should be able to look at that and say, well, that's what? 65. And then 75 cents and 15 cents is what? Yes, 65.90. That's what I want you guys to be able to tell me. 65.90 is now equal to X minus 45 over 2. Is everybody okay with that? Now, how did I get 45? Yeah, I just did the negative 20 and the negative 25. All right, now this is the case. All right, now I have division. All right, now this is the one time in which you have a fraction that you have to get rid of the division first. All right, so keep that in mind. So I'm dividing this quantity by 2. So how do I get rid of the dividing by 2 now, guys? Multiply by 2. So now I have X minus 45 is equal to, now we're going to practice doing our mental math here. 60 times 2 is what? 120. 5 times 2 is 120 plus 10. 130. 90 cents times 2. So my final answer is 131.80. 131.80. Is everybody okay with that?
Is that the right answer?
I didn't say that because we're solving for x, right? So now what do I do?
Add 45.
Add 45, and of course we can do the mental math on that. So x is equal to, so whoever said 176.80, pat yourself on the back. You are amazing. You are amazing. All right? Very good. Very, very good. Now, some of you guys are patting yourself on the back. You're lying. I know you are. All right? We just had a conversation in chapel about that. All right, here we go. That's very hard, guys. So do me a favor tonight or over the weekend. I always like to highlight the ones that I think are kind of important. That's a really good thinking question right there. All right? Now, absolute value. All right? Absolute value is always positive because it's always referring to a distance. When I say the distance from here to your house, I don't say it's -8 miles. Right? I never heard anybody say, draw me something that's -3 inches long. Right? So distance is always what? Positive. The negative, believe it or not, is the direction that you're moving, forward or backwards. All right? But you can't measure something with negative area or negative volume. All right? So we're talking about distance here. So here we go. Absolute value of 3 times -3 minus 2. So what's 3 times -3 minus 2? Good mental math. Be careful. Somebody tell me. I could be wrong, but I'm usually not.
11.
Yes. But I really want you to say it's -11, and then the absolute value of -11 is what? 11. Beautiful. If you don't know that, speak up. Yes. Okay, so I know this is tricky, so here we go. What's 3 times -3? -9. Minus 2? -11. True? So now absolute value of -11 is 11. Quickly, let's go. All right. Happy days? Any questions? Quickly, go.
So we put the value of it to make it positive after we solve it?
Yes, the absolute value, right? If I said, what's the absolute value of 5, you would tell me it's 5. If I said, what's the absolute value of -5, you would tell me it's also what? 5. All right, because we're talking about distance. Okay? Here we go. Number 13. So we would say 3 squared minus -2 cubed. So what's 3 squared, guys?
9.
Minus, what's -2 cubed?
-8.
-8.
So it's positive.
Agreed? So what's 9 minus -8?
17.
You are awesome. 17. Told you. Easy, easy. Everybody happy with that? All right, moving forward. All right, here we go. So now 2 times x minus y over 3 times y minus 2 times x. Notice I wrote the whole thing out so I didn't make a mistake because there's too many negatives there. Everybody agree?
Yes.
So here we go. What's 2 times -4? -8. Double negatives make a what?
Positive.
Over -9. Double negatives again, plus 8. Everybody see that? Now again, you're double checking how much you understand positives and negatives. That's what you're doing. All right? And now, what's -8 plus 3? -5. -9 plus 8. So my answer was, of course, what? 5. Yes, ma'am. Tell me.
The first part of the problem.
Okay, so blow this up. This just means 2 times x, right? So I just replaced x with -4.
But can you repeat that part where you changed it to -8 plus 3?
Yeah. So these 2 negatives right here made it plus. Do you agree with that? And then I multiplied a positive times a negative. That's how I got the -8. You good? All right. And then on the bottom, we did 3 times -3, which is -9, and -2 times -4, which is +8. You're good. Yes, sir. Quickly.
This class is almost over. Can I ask you a question?
No. No. All right. Just stay with me. I promise you I'm going to take good care of you.
Because it's -5 over -1, that means it's +5?
That is exactly correct. You with me?
Yeah.
You good? All right. Anybody else? All right, guys. Don't worry about it, guys. I promise you I'm taking care of you, all right? Don't worry about it. All right. Use cross products to determine whether each pair of ratios is a proportion. Yes or no?
No.
Now, I knew that quickly because I knew 17 times 3 is 51, and 14 times 3 is not 39. Does everybody agree with that? I'm not going to multiply 17 times 39 and 14 times. Although you could look at that and say, hey, look, guys, listen up to me now, please. You could also say that 4 times 1 is going to end in a what? 4, and 7 times 9 ends in a what? Therefore, it can't be a proportion. There's so many ways to do it without actually doing the multiplication. Does everybody agree with that? Yes.
I don't get how you know whether it could be a proportion.
Okay, so let's look at this. Look how easy this is. 1/2 is equal to 2/4. That's a proportion because they are what?
The same.
Equal. So if you cross multiply, the funny thing about it is, what is 2 times 2? And what's 1 times 4? So that's a shortcut. If you couldn't visualize it, you could do cross products and see that it's equal. What?
For the cross product, you have to multiply, so 17 times 39, 14 times 51.
That's what we did. Yes, that's exactly right. That's exactly what we did. But we're not doing that because we're smart enough to say, if I multiply 14 times 51, it's going to end in a 4, right? You understand that?
Yes.
If I multiply 17 times 39, it's going to end in a 3. So they can't be the same. All right, that's what I'm hoping to show you guys. All right, how you can think better. I don't want to multiply 17 times 39, even though it's not very difficult to do. All right, so here we go. Solve the proportion here. All right, now again, I'm hoping that's mental math for everybody. So let's see how we did last year. What is it? 20? Is that, did you say A is 20?
Yes.
All right, does anybody have any questions with that? Now you could cross multiply. You could also reduce 9/12 to what? 3/4, right?
And 15/20.
There you go. And 15/20 is also 3/4. All right, that's not a big deal. All right, now we got into some harder equations. All right, so I really want you to concentrate with me on this. All right, so here we go. 9 minus t equals t plus 3. I think you got to this last year, but I'm not 100% sure. So remember, variables always go on the same side. Numbers go on the other side. I always try to teach kids that I want to try to keep the variables positive. All right, so please watch now. This is what I want on your paper now. I'm adding t to both sides. And then I am subtracting 3 from both sides. Now, why do I do that? Because I want variables on one side and numbers on the other. Do I agree with that? All right, isolating the variable from the numbers. Now, what's t plus t? 2t. These do what to each other? Right, 9 minus 3. So 2t equals 6, correct? So t must have been what?
3.
T is 3. Everybody happy with that explanation?
Yeah.
All right.
Can you keep it up there for a second?
Yep. What?
Is it okay if I just did 9 minus, I just made it in my head that 9 minus 3 is 6 and 3 plus 3 is 6. So I did 2 is 3.
Well, yeah, but it can be harder. We're learning the process now. That's what I tell kids. All right. I don't care if you can do the mental math now. We're learning a harder process.
Okay.
All right. So you got to be careful. All right. So here we go. Now, what I'm going to do now is I'm going to grab this and pull it off to the side. It'll be easier. All right. I'm going to pull it right here. All right. So now here's what I want you to be able to do on this. All right. So I agree we're going to have to distribute, correct? When we distribute, I get what? 2y minus 12 equals. Now, please be careful. All right. I don't think you learned this last year. Did you guys learn about no solution?
No.
All right. So please watch. Please watch. This is tricky. What is 3y minus 1y? Tell me. What is it? 2y. So now I want you to put your hands up right now if you're not sure what I did. All right? You ready? All right, so all I did was I did the distributive property, right? I went 2 times y and 2 times negative 6. You agree with that?
Yeah.
That's not a problem, right? You did the distributive property. I know you did that.
Yeah.
Now over here, you have to combine terms.
Yeah.
What's 3y minus 1y?
2y.
That's where I got that. And then I just left with 2y plus 12, right? All right, now I really need you to concentrate. Listen to what I'm saying now. You want to be smarter today. Watch. Look up. Look up. No reason to write anything down. Is it possible for 2y minus 12 to be the same as 2y plus 12? Is that possible?
No.
If I start with a number and subtract 12, can I start with that same number and add 12 and say they're equal?
No.
You should be able to say that doesn't make any sense. Let's say it one more time. If I start with any number and I subtract 12, and then I start with a number and add 12, are they ever going to be equal?
No.
No. So if they're not equal, what we do is we say there's no solution. Or we say there is no solution. All right? Now, again, let me explain why mathematically. All right, if I'm isolating, I would do minus 2y and minus 2y, right? Well, what happens to the variables? They cancel out. So now you're trying to tell me that negative 12 is equal to 12. Does that make sense? No. That's why we say it's no solution.
Could y be a negative?
No solution. No solution. That's the symbol for no solution. All right? Not possible for that to be true. Not possible for that to be true. Everybody happy with that explanation? All right, again, so I finally taught you something after, this long week. All right, first thing I taught you. All right, let's take a look now at 19. Let's see what 19 says. Okay, now 19 is the hard one. All right, so let's do 19. I'm going to grab it down here. All right, here we go. All right, if you can do this one, you are in fantastic shape. You're in fantastic shape. Did you get an answer for this? What did you think? Did anybody get z equals what? 11. 11. Wow. 11. Wow.
11.
Now, don't say 11 just now because everybody's saying 11 now. Come on, don't jump on the bandwagon. I want you to say, I got 1 or I got negative 2. Right? Go.
I have 7,000.
7,000. I like it.
I got 7.
7. All right.
9.
All right, let's go. I like that. 9. Being different is good. Being different is good. All right. Now, let's see. I have to do the distributive property first here. Agreed? So 17 plus 3z minus 6 minus 11z equals negative 7z minus 14 plus 14. Look at that. Make sure you understand that. That is not difficult. That was just, do you understand the distributive property? Everybody agree with me?
Yes.
All right, now generally the next step is to combine terms. So what I'm going to do is I'm going to highlight. Somebody read that to me. What's this? So what's 3z minus 11z? Right, so I want everybody to write down negative 8z. Now you're going to ask yourself, what's this? What's the green? 11. So negative 8z, you have to tell me it's positive 11. Equals, now over here. What happens there?
Cancels out.
Right, that wasn't bad. So that equals what?
0.
Right. So I can just put negative 7z. Everybody okay with that? Any question? What?
So couldn't you combine negative 8z and negative 7?
You're trying to be one step ahead rather than with me.
Sorry.
Right? Come on, stay with me now. This is where I'm at right here. All right. Now I'm trying to isolate the z's. So how do I undo a negative 8z? What do I do?
Plus 8.
Yes, you add 8z. Now, if you think it's necessary, put plus 8z and plus 8z down. Do I care if you do that or not? No, because I feel like you should know what negative 7 plus 8 is. But what's negative 7 plus 8? 1z. So, beautiful work. For those of you guys who knew z was equal to 11, you can pat yourself on the back and say, man, it's good to be brilliant. Man, it's good to be brilliant. I appreciate that. All right, here we go. For those of you guys who did not quite get it, it's okay. Your chance to be brilliant is coming up real soon. All right? So, let's take a look now at question number 20. What time's the bell ring? 1 minute. I think you're right. So I'm going to hold it here. Listen, guys, here's what your homework is. Review the information that we did today, correct? Now, for some strange reason, I should be helping you. So now you might have some understanding. I don't really expect you to understand how to do 20 or 21, so I'll work with you on those. I do want you to tell me about number 22. I do want you to try the word problems, please. And then the ERBs are just great review questions. All right, so I want you to try those. And on Monday, guess what we're going to do? Finish this up. And then we're going to start chapter 1 review in the book. All right, it will be on your iPad. Everybody happy with that? All right, great job today, guys. Great job. Perfect time.